In this example, we'll explore the application of StarDrop's auto-modeler to build a QSAR model of potency against the Muscarinic Acetylcholine M5 receptor, based on a set of public domain data obtained from the Chembl database. The resulting model will be applied to an additional set of compounds to predict their properties and visualize the structure-activity relationship. Start by opening the StarDrop project file Muscarinic Acetylcholine Receptor M5 by selecting Open from the File menu. The first dataset displayed contains 129 compounds with measured activity against the muscarinic acetylcholine receptor M5. These data are Ki values in micromolar. However, to build a good model, the data should be converted to logged units. Logged units provide a more even distribution of values to model and a better correlation with the compound descriptors used to build the model. Therefore, we will use the mathematical function editor in StarDrop to generate pKi values. Select the f of x button on the toolbar to open the mathematical function editor. In the f of x field, enter the equation 6 minus the log of the Ki in micromolar. This can easily be achieved by pointing and clicking in the editor. Enter the name of the new column, pKi, in the new column name field and click OK. The new column containing pKi values will appear in the dataset, and now we're ready to build a model of these data. Change to the Auto Modeler area on the left and click on the arrow button to begin a new modeling session. The first page of the Auto Modeler wizard enables you to choose the type of model to build, continuous or category. You can also choose whether to allow StarDrop's Auto Modeler to split the data into training, validation, and test sets automatically, or to provide these separate sets yourself. Finally, you can confirm the dataset to model and the columns containing the property values to model and the compound structures. In this case, we will use the default settings, but we need to select the correct column to model. So, choose the pKi column from the Value column drop-down menu and click Next. The next page enables you to configure the parameters for the automatic selection of training, validation, and test sets. In this case, we will use the default set split parameters. So, just click Next. The third page enables you to select the descriptors to use. The built-in library of whole molecule and 2D descriptors will be used by default. More details are available by clicking the Select button, and new descriptors can be imported as smarts. Also, additional columns in the dataset can be used as descriptors. Finally, the parameters for selection of descriptors can be defined. Again, we will use the default settings, so click Next. The final page of the Auto Modeler wizard enables you to select the modeling methods to apply. The methods are categorized by their computational cost, and the methods selected by default will depend on the size of the dataset. We would recommend unselecting the intensive methods for this quick example, and then click Finish to begin the modeling session. The top section of the Auto Modeler area will provide a running update on the progress of your modeling session. If there are no other modeling sessions ahead of yours in the queue on the server, this should only take a few minutes. You can check the status of the server at the bottom of the Auto Modeler area. When the modeling session is complete, click the arrow next to the session in the Auto Modeler area to open up the list of models generated. The model with the best result on the validation set will be highlighted in red. Please note that the specific results you see may be slightly different to the example shown here due to a random element in the assignment of compounds to the training, validation, and test sets. Select the modeling session to see a table summarizing the results of the different models. This will show the result of the best model on the test set. Tick the validation set box at the bottom of the Auto Modeler area to see the results for all of the models on the validation set. From this, you can see that the Auto Modeler has built a model with each of the modeling methods and compared the performance for these for the validation set to identify the most predictive model. This best model is then further validated using the external test set. A robust model should have good performance on both the validation and test sets. Select a model to see a plot of the results for the validation and test sets and confirm that the model is producing reliable predictions. You can hover the mouse pointer over a data point to see the corresponding structure. If you're happy with the results for a model, you can save it so that you can apply it to new compounds to predict the potency and visualize the structure-activity relationship. In this case, we'll save the random forest regression model. So, right-click on the random forest regression model under the modeling session in the AutoModeler area and select the Save Model option. In the Save Model dialog, enter an appropriate name, set the units to pKi/PIC50 and click OK. If you wish, you can also enter more information in the long name and description boxes. Finally, navigate to a convenient directory and click Save to save the model. The resulting file can be shared with any other StarDrop user who can load and use the model in their copy of StarDrop. Switch to the Models area and you'll see that the model has appeared under the corresponding directory name, ready to run on new compounds. We'll illustrate the application of this model to an additional 10 compounds that were not included in the dataset used to build and validate the model. Change to the new compounds dataset by clicking on the tab at the bottom of the dataset. In the Models area, select the new model we've built along with any other models you would like to run by ticking the boxes next to the models and click the arrow button. The new model can be used in the same way as any other model in StarDrop. For example, selecting the column header will display the glowing molecule visualization for each compound, showing the structure-activity relationships captured by the model we have built. Changing to the Design area and selecting a row in the dataset will enable you to explore optimization strategies guided by the glowing molecule. This has been a quick example of the application of StarDrop's AutoModeler. There are, of course, additional features enabling expert modelers to control the parameters of the model building process and explore the detailed results for each model. For more information or to arrange a comprehensive demo, please contact StarDrop support at optibrium.com.